I'm going to have some detailed diagrams of free body diagrams which you will need to solve the problems later on. Right?
Okay.
I'll from some other book, and then we'll finish the remaining chapter.
Okay.
Now see here, application of Newton's laws. Now this is a very basic thing. First of all, there is a block under tension, right?
Mm-hmm.
This is very primary thing which you are knowing also. That block is in equilibrium, so tension equals mg. That is a free body diagram, right?
Yeah.
Now I'm switching over to the next page, which I'm showing you here is this. Here you can see, not this one, 34th page number. Yeah, here there are two blocks connected.
Yeah.
Right now, and on one of them force is applied.
Yeah.
Now you can see the force on M2 here. That is one is M2G, then that is tension, then normal force, and then force.
Force. Okay.
You have to identify all the forces, huh, beta?
Yeah.
And here on the M1, that two vertical forces are there and one horizontal, that is tension, right?
Tension. Okay.
Vertical forces are N1 and M1G, which balance each other.
Mm-hmm.
And comes another page. Page 6 here. Now you can see here there is one mass tied with two strings.
Yeah.
So in this case, in QR, there is going to be tension. In PQ also there is going to be tension.
Mm-hmm.
In vertical string also there is going to be tension.
Yeah.
And that detailed diagram is shown here. Here is T1 in that slanting string, and it is resolved into two components: T1 cos 30, T1 sin 30.
Mm-hmm.
Then in string T2 is there. Now, actually, what will happen here? T1 sin 30 will balance T2.
Okay. T1 cos 30.
Yeah, and T1 cos 30 will balance T2, and T1 sin 30 is going to balance 17 Newton.
Okay. So you
Right?
can find T1 from that, and then you can find T2 from T1 cos 30. Okay.
It is missing. You can find out
Yeah.
T1 and T2. I'm showing you these questions because otherwise later on you may find that this is not done. Then instead of it, that is a good thing.
Okay.
But, just a minute, I have a phone call to be attended.
Okay.
બોલો. કાલે 1 વાગ્યાનું નહીં બેટા, કેમ? હા, પણ એટલે હમણાં જયારે શક્ય બને અને હમણાં બીજે જવાનું નથી ને ત્યારે હું સવારના લઈ લઉં ને યાર, એટલા માટે કાલે કરીશ. પછી મંગળવારે મંગળવારે થોડું મોડું કરીશ. મોડું કરવાનું શું થાય કે મારે 7:30 સ્કૂલ જવા નીકળવું પડે, એટલે 7:30 થી 7:30 જ લેવું પડે એવું. બપોરનો ટાઈમ ખરો બેટા, પણ કાલે જયારે સવારનો ટાઈમ થોડું તું મોડું કરીને અડધો કલાક મોડું કરાવે, એમાં પછી મારે દોડાદોડી થઈ જાય. હું આઈ થિંક ટાઈમસર સ્કૂલે ના પહોંચી શકું. અને પેલામાં મારે આવીને સીધું જમ્યા વગર ત્યાં સીધું પહોંચવું પડે. એટલા માટે હું બને ત્યાં સુધી સવારે તને આપવાની વધારે ટ્રાય કરું છું. નહીં તો આમ તો પછી પેલું રેગ્યુલર પેલા લોકોની એક્ઝામ પતી જશે પછી તારો બપોરે 1:30 ટાઈમ, 1:45 ટાઈમ. So here you can find out all both T1 and T2, right?
Yeah.
Okay. Now here there are two forces.
Okay.
I mean there are two vertical two blocks tied vertically with two strings.
Mm-hmm.
Now here no, not this one, but even you can try solving them. You can find out T1 and T2. This is simply a problem. Now here you can see the pulley system.
Mm-hmm.
In pulley system, what will happen here? If you see the free body diagram on M1, that is the top one, T will be equal to M1G.
Yeah.
Now on the other also it is T is equal to M2. No, T is not equal to M1G, but due to if M1 is greater than M2, then what will happen? The whole system will move in this way.
Yeah.
M1 will come down, M2 will go up, right? And
Mm-hmm.
acceleration suppose is A. Then M1G minus T is equal to M1A. That will be equation.
Equation. Okay.
And on the other side, T minus M2G should be equal to M2A.
Hmm.
Now, sometimes they may also ask that what is the tension in the string which
Pulley.
is tied with pulley here. Then in that case, this is going to have this force on this pulley. I mean, force in this or tension in the string, which is tied to pulley and ceiling, is equal to T plus T 2T. It is going to be,
Okay.
which is page number 39. Now 40. Now this one here. There can be friction also between M1 and surface, right?
Hmm.
In the vertical string, M2G minus T should be equal to MA,
Hmm. Yeah.
and here there is no friction mentioned here right now. But if friction, so in that case T is equal to M1A, but if friction is a T minus F should be equal to M1A.
Okay.
And friction, how can you find out if coefficient of friction is given? I mean that normal force into coefficient of friction you have to do.
Okay.
So it's diagrams are shown here, but that I have explained you already.
Mm-hmm.
Now this one, see here there is a slope, and on that there are two masses,
Yeah.
M1 and M2. So here we have to look at it. It's a free body diagram. Say for example, this is for M1 given.
Mm-hmm.
So normal reaction M1G here, M1G cos theta is here, M1G sin theta here, and here tension T.
Okay.
If friction is there, friction we have to think about.
Hmm.
Okay. Now in the same way for on the other body.
Hmm.
Now on page number 51. Now we are on that page. Yeah, 51 page of block. Right?
Mm-hmm.
Here G sin theta is the force driving it downwards, but frictional force will have to be subtracted. So resultant force is going to be equal to mg sin theta minus fk.
FK. Okay.
And balance mg cos theta. Mg is not shown, but that is understood. And 54. Yeah, here is the 54. Now this is crucial, huh, madam? Just
Okay.
look at it. Here there are two blocks kept over each other, and the smooth surface is there, but between two blocks there is a friction.
Yeah.
So in this case, now force is applied on the lower block. That is, then what is going to happen due to friction? This M2 is also going to be dragged along with that.
That's it.
If this net force is uh, less than or equal to the friction between these two,
Okay. The
and
frictional
then
force.
in that case, this type of sums will come,
Yeah.
may come rather, not will come, may come. At that time, you will need to pay attention. If
Hmm.
you want, I can just send you these things also later on,
Okay. Yeah.
right? I think these are useful things. And now, if force is slanting, yesterday we had to see one thing, no?
Yeah.
If force is making some angle horizontal,
Mm-hmm.
then mg force will be downwards, normal reaction will be upwards, f sin theta upwards, f cos theta will make it move.
Okay.
And friction is in this direction.
Mm-hmm.
Now, there is push, like pull. This is pulling, but this is push. Then here in this case, this is f sin theta, f cos theta is here, the normal reaction is upward.
Okay.
And here, they may apply force on the upper block also.
Mm-hmm.
So all these things we have to think. Lastly, now 15 page quickly. Now this I wanted to show you. Here, when suppose here there is a pendulum suspended here,
Mm-hmm.
and this cart is accelerated with acceleration a, then what is going to happen? Due to that pseudo force, that pendulum will go in this direction.
Yeah.
That you can see. So there is going to be tension, two components of tension, T cos theta and T sin theta.
Mm-hmm.
T sin theta will equate the acceleration, whereas T cos theta will balance mg.
Okay.
Okay. Now this is something I wanted to show you here in this. Now here there are some illustrative. Actually, I can send you these problems also, illustrative problems, so that you can understand them better.
Hmm.
Yeah, right now we are on your textbook, the drag force terminal speed. Now we can classify substances into three types: liquid, solid, and gaseous, right?
Yeah.
But solid different property than liquid and gases.
Hmm.
Liquid and flow, solids cannot.
Hmm.
So anything that flows is known as a fluid. So
Yeah.
in fluid we can have and liquid, both.
Mm-hmm.
Now, because there is a relative motion in a fluid, there is some force opposing to the relative motion produced, and that is known as a drag force.
Mm-hmm.
Force is acting opposite to motion. Sorry, it is in the direction of relative motion. I'm sorry. Now I can give you an example. Something like, say there is a liquid, and in that I can drop a steel ball,
Mm-hmm.
and there are going to be various forces. Here, I'm not talking about. I'm trying to explain it in a different way, because you may come across this example later on, also in fluid chapter. That
Okay.
steel ball is moving in a liquid, then it is acted upon by various force. One is mg, it is downwards, that is gravitational force. Second will be buoyant force exerted by fluid on any body which is fully or partially submerged in it.
Hmm.
Then there is third, there is a viscous force also. All these forces together force the more. Only if it down, the other two forces are opposing the motion. So they
Okay.
are drag forces.
Yeah.
So in this condition, How do we consider relative motion? Actually, we can consider that steel ball to be stationary. Then fluid is moving up. This is what we can imagine.
Hmm.
So you can again think another example that the raindrop is falling in air.
Yeah.
So with respect to rain, that fluid is dragged. So drag force will be there in the direction opposite to the direction of motion of
The
rain
raindrop.
liquid,
Okay.
raindrop.
Hmm.
Now here, this drain force is given by D is equal to half C into rho into A into V square.
Mm-hmm.
Rho is the density of, here we are going to consider very simple cases here for air only,
Okay.
right?
Yeah.
Then for drag, drag force is given by this formula. So C is the constant. It is not a very much constant. Its value varies from zero point 0.4 to 1.
Hmm.
Rho is the density of air, A is the area, and V is the velocity. So it depends on velocity square.
Hmm.
So this is the drag force, right? Now there is another force, gravitational force acting
Mm-hmm.
due to D minus Fg. That should be the force that should be the net force acting on a body.
On the bottom. Okay.
So in that case, here again they are inserting the value of drag force, that is half 0 A into V square into minus Fg. Now suppose what happens slowly due to this opposing force, its velocity will keep on reducing.
Yeah.
The drag force itself, which is dependent on velocity, that itself reduces velocity.
Velocity. Okay.
Right? So at certain stage, what will happen? This net force will become zero. Acceleration becomes zero.
Hmm.
And when net force acting on it is zero, there is no change in velocity. So velocity will remain constant, and that velocity is known as terminal velocity.
Terminal velocity. Okay.
Right?
Yeah.
Okay. And that terminal velocity can be found out using the formula 6.16, that is Vt. V terminal is equal to square root of 2 Fg upon C rho into A.
Okay.
Now, drag force is very crucial actually, but I mean, many places it plays a great role. Like, say, something like a person who is doing skiing, or something like, say, here, as it is shown in skydiving and all that. This
Mm-hmm.
plays a very crucial role. Now, it's your turn to see the sample problem.
Okay. Raindrop with radius r equals 1.5 millimeter per meter. That is at height 1200 meter. And c equals 0.6. Assume that the drop is spherical throughout the fall. The density of water 1000 kg per meter. Wait, so why did they give the density of water? Is it? I mean, you would only use density of air because the raindrop is falling through the air, right?
What happened? I just missed you.
Why did they give the density of water?
Density of water.
Because
Yeah, it is given better to calculate mass of the raindrop,
mass under. Okay, okay, I see. Then
and hence they have to calculate weight.
wait,
That is gravitational force.
force. Yeah. Okay. So then,
See, here it is very clear, no, that you can see 8. The 2 is already there. 4 upon 3 pi r cube is the volume,
up cube. Yeah.
the raindrop into density. Then that force will come, no, into g.
The kilograms. Okay. Yeah. And that's the mass of the raindrop. Okay. So this would be 3 over 2000. Then 1 by 3 times 3 cubed. Okay. And then if we say it's 1000 per meter. Okay, so times 1000. So the mass is a very small number, and
Hmm.
then 1 second.
But don't calculate them separately. Calculate one thing only. Finish. That is VT. You have to plug in the values only, no?
Okay, yeah, I see.
Hmm. Otherwise, if you, calculate them separately, say one after the other, we may end up in with some different answer also,
Mm-hmm.
because every time we calculate the things, we take something approximate
Hmm.
that we should not do.
Okay. 4 third by R P over Q G. And then you have V of the terminal velocity equals to 2 F G over C over R E. How did they get the A for the terminal velocity?
A for terminal velocity. Yeah?
Hmm.
Wait a minute. Let me see the sum. Table A indicates in table 6.1, table 6.1. Excel, that is A. A is the area, na? Yeah.
Yeah.
This A you are asking about.
Yeah.
That is area, that is pi r square, effective cross section area of the water drop.
Of the water drop. Okay, yeah. So that makes sense. Okay. So A makes sense.
There is something in part B.
Hmm. What would be the drop speed just before impact if there was no drag force? So
It would have been free fall only, no?
yeah,
So square root of 2 GH.
it's yeah. Okay.
You can calculate and you can vary.
Hmm.
Now, uniform circular motion. Actually, we have studied this topic earlier also. Why they have
Hmm.
put it again, I don't know. But in uniform circular motion, acceleration is equal to v square upon r, and that is towards the center.
Mm-hmm.
Here they are discussing one example. Okay, suppose you are sitting in a car on the back seat, and you are sitting in the middle. There is nobody else, and your car is moving with high speed, and all of a sudden there is a sharp turn. So what is going to happen? You are going to be pushed on the other side,
Hmm.
right?
Yeah.
This is happening. They have not discussed the reason. They have not considered that pseudo force. They are trying to explain that in different way. But we consider pseudo force, that is easier to understand. Centripetal force is acting towards the center, that is required. From where does this centripetal force come? So in order to show that, look at this diagram. Now here, what happens in circular motion? Every time velocity is here in this direction, centripetal force is perpendicular to it. So
Mm-hmm.
velocity and centripetal force both keep on changing the velocity, and they are both mutually perpendicular. Now suppose your car is moving on circular track like this. So what
Yeah.
happens here? When car is moving, that frictional force provides the centripetal force,
Oh, okay.
right? So
Yeah.
in this case, they have not discussed, but let me finish that also. So here in this case, what happens that what are the forces? These forces are shown here. Normal reaction, mg and fs, right?
Hmm.
So n is equal to mg.
Yeah.
Then in that case, what is frictional force? Frictional force Fs is equal to mv square upon r. So mv square upon r, that is equal to mu s into mg.
Hmm.
So from the and actually that centripetal force should be less than or equal to the maximum frictional
No
force.
force.
Then car can stay there on the road.
Okay.
So velocity of car moving on such path should be less than or equal to square root of mu s into rg.
Okay.
Now, actually, while giving curvature, they are also stating what is the maximum safe speed.
Hmm.
Barabar?
Yeah.
And sometimes this friction is not good enough. Then what do? They make the road slanting. And if you see the racing tracks, somewhere they are having slopes like this, as it is shown here in this diagram.
Hmm.
So in that case, a part of normal reaction and friction both together provide centripetal force.
Force. Okay. Yeah,
And
because
after doing all this majuri and after all doing all this calculation and all that, they give us they calculate the velocity. This velocity, maximum velocity, is given by this formula: Vs is equal to square root of Rg into mu s plus tan theta upon 1 plus mu s tan theta. This you don't have to bother about. I'm just telling you for your knowledge. I mean, just to tell you.
yeah. Okay.
Uh, After all these calculations and all that, when they mention such safe speed, and if you drive at much speed more than that, your vehicle is likely to get an accident.
Hmm.
So we should obey the traffic, their instructions, right?
Oh.
Now here, if suppose there is a planet or rather say satellite orbiting around the Earth, like this, they are stating it is Puck, but here I say some satellite moving around the Earth. Then in that case, suppose this is the Earth and this is the satellite, it is moving around the Earth, so centripetal force is required.
Okay.
From where does the centripetal force come? Again, it is from gravitational force.
Mm-hmm.
Okay. So here in this way, your chapter theory is almost over.
Mm-hmm.
Now you can have checkpoint 2.
Okay. So to loop is a circle with radius r equals to 2.7.
My dear, first see your checkpoint 2, then
Oh,
go for
okay.
sample.
I see. I see.
Meanwhile, I'll have a glass of water and I'm coming.
Right in the first. B. What is the direction? Acceleration E. So,
Hello?
hello. Yeah. So, for the checkpoint 2,
Uh,
I know for the highest point, the acceleration will be down, and
uh,
then for the lowest point, the acceleration will be up. But then
what about normal reaction?
normal reaction would be opposite to that.
No, normal reaction will be normal to the surface.
surface.
When
So
it is upwards, when it is on the highest point,
point.
normal reaction is offered by the surface, no?
Okay.
So it is going to be downwards only. And when it is at lowest point, it is going to be upwards.
Okay.
Now, see the sample problem. Why your video is gone?
I
Or
turned
my
it off
video is gone?
because otherwise your video wasn't coming clear. So I decided that if I turn it off, then it started becoming more clear. So that's why I turned it off.
Okay.
Um.
But you can see I mean, screen,
Screen.
no?
Yeah, I can see it. Uh, so the loop is a circle with r equals to 0.7. It is the least speed v that he and his bicycle could have at the top of the loop to remain in contact with it there. So this is the velocity and the normal force in the loop. So this is bicycle, gravitational force and the normal force. So negative f for n minus f for g to m of negative a. What's it? Hmm. F for n minus f for g. This is mg equals to m negative v squared over r is 2.7.
See here, you can make out at highest point what are the directions of normal force, acceleration, and gravitational force they are shown. Centripetal force is obviously going to come down. Normal
Yeah.
force is offered by the surface only.
Yeah.
So it is going to be down, and gravitational force is
It's
also down.
down. Yeah.
In that case, minus Fn minus Fg should be equal to minus Ma. All of them are vertically down.
Down.
And acceleration is v square upon r.
Mm-hmm.
So actually now what happens if this velocity is just enough for that person to reach on the top, what will happen at that time? He is about to lose the contact with that. He is about to lose the
Mm-hmm.
contact with the surface. When he is about to lose contact, in that case Fn will go. Fn, when normal force is lost.
Okay.
Or that you need to be in contact with the surface, right?
Yeah. In order to have normal force.
So in that case, normal force goes away. So mg is equal to mv square upon r.
R. And then m cancel out. Okay, so v is equal to square root of gr, and so v equals 5.1 meter per second.
Yeah, here only this motion is considered. Energy conservation is not taken into consideration, not even momentum.
Mm-hmm.
So this is the answer. In future, you may get some other answer.
Okay.
Now, next are in a flat circular turn.
Mm-hmm.
Probably whatever I have discussed is going to come.
Hmm.
See the sample problem.
Observing this in a modern centimeter pushing past, allowing the car to travel much faster through a flat turn. Feeling the downward push for negative lift. This car has so much negative lift that it could be driven upside down on a long ceiling. It represents a Grand Prix. Race car of mass M because of the shape of the car and the wings on it, the passing gear exerts a negative lift downward on the car. What is the magnitude of the negative lift acting downward on the car? Car. The frictional force is shown in the negative direction of the radial axis. Okay, so the frictional force will be negative because it's pointing in the negative direction of the axis,
Yeah.
and the velocity.
Mhm.
Why is the velocity also negative?
Velocity is not negative, but v square upon r is taken negative because it is vertically down.
Is vertically down?
Yeah, it is
How?
centrifugal.
Okay, I see. Um,
Have you seen the full sum or you have seen a part of it only?
no, I've only seen the first part. I'm looking at the vertical calculation.
Okay.
So let's consider the vertical forces on the car. The normal force is directed up and positive. Okay, so the normal force equals to gravity plus the um, negative lift. So that's fine. Now combining results.
Mm.
Um, okay, so we know what normal force is,
Yeah.
and so F of L equals to F of the normal force minus mg. Okay, so
Mm.
they solve for Fn and then they put it inside, and they solve for the force. Okay, so that's how they got the negative lift. That
Yeah.
made sense. And then part B, they are asking for the magnitude of the negative lift at a speed of 90 meters per second square. So in part A, they were going at 28.6 meter per second square.
Now we have to plug in the value.
Plug in the okay the value. Yeah, okay. I think it makes sense.
Yeah. Now here I think in the diagram they are trying to show the more or less similar thing
Mm-hmm.
which we discussed. This is a level road and this is the centripetal force, this is the velocity and this is the free body diagram also. Acceleration is towards the center provided by this frictional force,
Mm-hmm.
normal force, gravitational force, and this is negative lift also.
Okay.
The negative lift was not thought about in the diagram I showed there because that was not about racing car. It was about normal.
Normal car.
Now the next one
Hmm.
are in a banked circular turn. Bank that is having some slope.
Hmm. Curved portions of highways are always banked to prevent cars from sliding off the highway. Highways derive the frictional force between the tires and floor surface event. Back to this. 611A represents a car of mass m as it moves at a constant speed of 20 meters per second around a banked circular track of r equals 190. It is a normal car, which means any vertical force from the passing car is negligible. If the frictional force from the track is negligible, what bank angle theta prevents sliding? So then you know that the um, track is tilted. So then the car, there will be a F of G, and then the normal force will be tilted, right? Because the car is tilted.
Yeah, definitely.
Okay.
Here it is shown also. No? See, you can see in diagram.
And then,
Fn, there is normal force is tilted.
and then since there is no frictional force, the only force that is the radial force,
Radial component of Fn.
Fn, yeah, is the okay, Fnr. And then there is a Fny which counteracts the F of G.
Yeah.
So you just say that the negative f of n sine theta equals to m squared over r. Here also they said the whole term the v squared over r is negative. Why did they do that?
Why they are taking negative? Huh?
Yeah, I still don't understand.
Here Fn sin theta also they have taken negative.
That is because it's going to the left of the car.
But Fn sin theta only provides you that mv square upon r, no?
Yeah.
If you take Fn sin theta to be negative, the mv square upon r should also be given negative sign.
Then what is the point of even giving f of n sine theta negative?
This is simply maintaining sign. I mean, you should be habituated to put sign. For
Okay.
that, there you should not leave the habit of putting sign. Otherwise, you will not use it only with that.
Okay, so then you can just find what f of n the y component of the normal force is. And so you know that f of n cosine theta is equal to mg. And then they divided equation 6.23 by 6.24. Okay.
Yeah, so that you can eliminate Fn and you can get tan theta directly.
Directly. Okay. And then you can just solve for theta.
Yeah. Now, actually, in this case, V will be equal to square root of here into tan theta. And when almost there is no friction, right? Such a speed is known as optimum speed,
Okay.
where there is very less wear and tear in the tire. Now comes review and summary. So we are ending the chapter. So your work is going to be great in the next week. Here somewhere you can see that two block problems which I told you, no?
Yeah.
Somewhere it is going to come. So let it come first. If it is necessary, we'll take it up in the next session.
Okay.
Because first you should try. That is what I believe.
Yeah.
So we we are going to end up today here only because we have done our thing.
Yeah.
And now, where is your mom?
I can call her. 1 second.
This is the one.
બધામાં બોલાવવાનું હોય.
તને ખબર હોય કોને બોલાવવાનું.
હેલો. વેટ
હેલો.
હેલો.
હા હા સર.
કેમ છો? મજામાં?
બસ 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 એકદમ ફાઇન. તમે
દેખાતા નથી. તમારી છોકરીએ વિડીયો ઓફ કરી મૂક્યો. બોલો.
હા એ કંઈક રેકોર્ડિંગ કરતી હતી ને એટલે આઈ થિંક હવે હા હવે દેખાશે. એ રેકોર્ડિંગ કરતી હતી એટલે એને મને લાગે છે બંધ કર્યો લાગે.
તમને પેમેન્ટ કેવી રીતે તમે કેવી રીતે પ્રિફર કરશો? એટલે હું યુઝ્યુઅલી લમસમ લેતો હોઉં છું.
હા.
એક સેમેસ્ટર પતાવવામાં $750 જેવું લેતો હોઉં છું.
કેટલા?
$750 એક સેમેસ્ટર પતાવવાનું.
એક સેમેસ્ટરના $750.
હા.
ઓકે ઓકે ઓકે. તો પણ હું તો તમને રૂપીસમાં જ અમે આપી દઈશું એટલે ત્યાં ઇન્ડિયાથી જ હું તમને ટ્રાન્સફર કરાવી દઉં તો ચાલશે કે કઈ રીતે છે?
તમે ગમે ત્યાંથી ટ્રાન્સફર કરો તો ચાલશે, ચાલશે.
બરાબર બરાબર. હા તો હું જરાક પૂછી લઉં મારા હસબન્ડને કઈ રીતે કરવું છે.
અને એવું હોય તો તમને પછી મારી બેંકની ડિટેલ આપી દઉં.
હા 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 બરાબર બરાબર બરાબર. યા 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 યા. તો પછી હું તમને ઇન્ફોર્મ કરું કઈ રીતે કરશું આપણે. ઓકે. હલો.
હા હા સાંભળું છું બોલો.
હા એટલે હું તમને ઇન્ફોર્મ કરું કે કઈ રીતે કરશું.
ઓકે.
ઓકે. યા.
હા હા.
ઓકે. તો વાત કરવાની તમે કઈ? ના. ઓકે 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 ચલો.
હા.
language. ₹50,000 I know. Sine કહું 750 બોલ્યો ને. બંદા સુધી 750 બોલ્યો. માસી વાત કરશે.
વધારે કે
બહુ વધારે, 50,000 રૂપિયા થયા.
પેલા તો મને થયું 150. 750.
મને તો એ જ સમજાણું.
મને એ જ સમજાણું પછી બીજી વાર બોલ્યા તો